Hello everyone, and welcome to another GIS lecture video. And in this lecture video, I want to continue our discussion on this idea of coordinate systems and map projections by talking about how we can categorize or describe the relationship between this reference globe, which again, right, is an imaginary globe that we've shrunk down to meet the reference scale, which is the intended scale, which is the relationship between the real world and the eventual map. And this thing called the developable surface, which I said was an imaginary piece of paper that we've wrapped around or interacted with the globe in some way. The idea being that we take the projection source, shine light from the source onto the developable surface, it passes through the reference globe, and then we just trace where the globe is being projected, hence why it's called a projection, onto the developable surface. What I want to do in this video is I want to talk about, well, okay, how can we have these interactions, right? In this case, I've kind of just drawn the developable surface as a flat sheet of paper against one side of the reference globe. But we can be more creative than that. And in this video, I want to talk about what we can do and some categories and names that we can use. So what I want to get out of the way up front is this is not an exhaustive list. Right, the things that I'm talking about now are just covering the majority, and the majority of the ones that you will use most often. But especially with modern mathematics sort of doing all kinds of more advanced things, some of these concepts break down in certain applications. But by and large, what I'm talking about is going to handle the vast majority of map projections that you're going to come across, and it's going to cover the most common map projections that you're going to use. So what I want to do is I want to cover something called class. And again, what we're talking about is how to categorize map projections. And how we can describe the relationship between the developable surface, the reference globe, and the projection source. So the first thing that we're going to do is we're going to describe something called class. And basically what class does is class describes the shape of the developable surface. So the shape of the developable surface. And so what I want you to think about before I draw any diagrams or talk at all is I want you to think about taking a soccer ball and a sheet of poster board. Right. In this example, the soccer ball would represent the reference globe and the poster board would represent the developable surface. And if you remember back to the diagram we drew in the last video, and we talked a little bit about it earlier, the idea is that we want to make it so that the poster board, right, the developable surface, is in contact with the reference globe, in this case, the soccer ball. And I want you to think about all the different ways that we could bend that developable surface, right, bend that poster board so that it touches the reference globe. So there are all kinds of options, and what I want to do is I want to talk about the three most common that we call the classes of developable surface. Okay. And so what I could do here is I want to talk about the three most common. right? So the first option we kind of already looked at, and that's we just leave the developable surface as a flat sheet, right? When we leave the developable surface as a flat sheet, we typically tend to call this a planar projection. Right? Or sometimes you'll hear it called a stereographic. Planar or stereographic. The idea being here that the relationship between the developable surface and the reference globe is such that the developable surface is kept as a flat sheet, and I'm going to make a note here that it only touches the reference globe at one point. We'll talk more about why that's important, and we'll talk about some variations of that in a moment. The next thing to consider, right, is what else can we do? Well, what if instead of keeping it flat, what if we wrapped it up? Think of it like a paper towel roll, right? And instead of having it be flat, we wrap it up like a paper towel roll. So instead of it being like this, right? Instead, what we do is we wrap it up like this. Right? With the reference globe inside of a cylinder. So the developable surface forms a cylinder around the reference globe. Right? So this is a cylinder. We call this a cylindrical projection. And in the next video, when we talk about distortion, we'll talk about why you might want to do this versus the next option. Right? So for this one, think back to when you were a little kid and you would go to Chuck E. Cheese or some other arcade for a kid's birthday party, and they would come out with the cake and they would have those little paper party hats that you'd put on with a little string. You'd put it on your head, right? Now I want you to imagine for a second that your head is a reference globe and that party hat is another way that we can bend the developable surface. Right? So what we can do is we can bend the developable surface, right, to look exactly like that party hat that you wore as a kid. Right? Something like this. Right? So we would call this, right, a cone. And the projection we would call a conic projection. Okay. So, why does the class of map projection matter? Well, I want you to think about for a second, if you were to take these and you were to cut them open, or take the planar projection and move it away from the Earth, what would you be left with? Well, if we have the map, let's just, for ease of explanation here, right, let's keep the projection source in the middle of the reference globe. And let's imagine, right, that we have light coming out. Let's just go ahead and have it come out kind of like this in all four examples, right? The reason why the class of the map projection matters is you can see from this example, right, is that the only places that are going to be captured are the places where the projection is going through the reference globe onto the developable surface. And depending on the shape that we make the developable surface, right, parts of the Earth are going to be missed because there's simply no developable surface there to capture the projection, right? So in the case of a planar or a stereographic, right, you might be missing significant portions of the Earth's surface when you project it because there's simply no developable surface there, right? Same thing with the conic, right? In this case, right, almost half of the Earth is being missed because there's no developable surface down here to catch that projection. Okay? So the class of the map projection is going to have a very large impact on the way the final map looks because of the relationship between the projection source, the reference globe, and where the developable surface is or isn't, or maybe the distance, right? If you can imagine extending this cylinder up to infinity, right? Eventually it will catch a line like this, right? But it's going to be way the heck up here. And again, right, any difference between where the reference globe is and where the developable surface is, right, any distance that this has to travel beyond the reference globe, that's called distortion. So you can imagine the amount of distortion at the poles on a cylindrical, right, versus at the pole on a conic. Okay. So again, this is conceptual, right? This idea of planar, cylindrical, and conic, this is conceptual, right? We're conceiving about how this works. In reality, it's mathematics. But you can conceive of how, right, this map projection is going to capture the northern hemisphere very differently than this is going to capture the northern hemisphere. Very differently than this is going to capture, in this case, half of the northern hemisphere won't even be captured, right? So that's how we handle the idea of class. This video is getting a little bit long, so I actually want to break this up into another video. So at this point, we've covered that we can change the shape of the developable surface by either laying it flat against the Earth, wrapping it up in a cylinder, or creating a cone and placing it on the Earth. So as always, if you have any questions, please reach out. Thank you.